Neet previous year question, thermodynamics. Let us read the question. The bond dissociation energies of x2, y2 and xy are in the ratio 1:0.5:1. Here bond dissociation energy is given. Now we will see bond dissociation energy of x2. Bond dissociation, bond is breaking. So which bond is breaking? Bond present in x2 is breaking. So x2 we will take x2 contains 2 x atoms. X is mostly halogen. Between halogen atoms single bond is possible. For example, F2 we will write F single bond F, Cl2, Cl single bond Cl, and etc. So x2 is nothing but x single bond x. Now this bond is dissociating. Dissociation in the sense this bond breaks, for which we have to supply energy. The bond breaking to give x atoms, it should be in gaseous state. To break this bond we are supplying energy. That energy is called bond dissociation energy of x2. Now this x2 we have to take 1 mole. We have to convert 1 mole into so and so atoms, for which what energy is required, that is called bond dissociation energy of x2. Next we will see bond energy of x2. Bond energy of x2, this meaning is formation of x2. So x2 is formed. From where? From x atoms. Take x atoms in the gaseous state. X atoms combine to give x2. Here bond is produced. Formation of bond releases energy. So it is called bond energy of x2. It is called amount of energy released during bond formation of 1 mole of x2. It is exothermic. This one is bond breaking, energy is required, so it is endothermic. Now let us compare the energies of these two. Bond dissociation energy equation is so and so, bond energy equation is so and so. These two equations are just reverse to each other. Therefore this magnitude and this magnitude, will they be equal? Sorry, they will be equal. So we can say bond dissociation energy of x2 is equal to bond energy of x2. Then what is the difference? Difference is one is endothermic, another one is exothermic. Therefore they are equal in magnitude and opposite in sign. Okay. So bond dissociation energy means what we have understood. We will see next line, second line we will see. In the second line it is given delta H for the formation of xy. Delta H is called enthalpy change or enthalpy of reaction for the formation of xy. Formation of what? xy. What is produced? xy is produced. What is formed? xy is formed. So for this what is the product? This sentence says what is the product? Formation is the product. So what is produced? xy is the produced. So what is the product? xy is the product. So xy is the product. We will take xy is the product. For this they said delta Hf, enthalpy of formation of xy. Enthalpy of formation of xy is given minus 200 kilojoule per mole. Now product we have written. We have to write reactants. Reactants is constituent elements. Reactants is what? Constituent elements of product. So constituent elements of product in the sense the product is xy, in this X is one element. So X is one element, X is halogen, therefore we will take X2, that is given, X2 given. And Y is another element, that Y another element formula is given Y2. So X2 plus Y2 gives XY. Now enthalpy of formation of XY, enthalpy of formation of XY is equal to minus 200 kilojoule per mole. Per mole is given. Per mole means 1 mole of XY is formed. See that? Per mole means 1 mole of XY is formed. So keep this as 1 mole and balance the rest of the equation. So in order to keep this 1 mole, X is 1, so multiply X2 by half and Y2 also by half into 2 1, here also 1. So we got the required equation we got. Next, the bond dissociation energy of XY will be. So bond dissociation energy we have to find. For this enthalpy of formation is given. What we have to find? Bond dissociation energy of XY we have to find. So regarding XY, delta H is given. Regarding XY, bond dissociation energy will be asked. So XY bond dissociation energy we have to find. XY delta H is given. That means, will there be any relation between delta H and bond dissociation energy? Delta H and bond dissociation energy, is there any relation? Why should we relate? Because for XY they are asking bond dissociation energy. For XY delta H is given. So there should be a relation between delta H and bond dissociation energy. Otherwise how to calculate? Okay. This indicates delta H and bond dissociation energy relation is there. What is that relation? That we will see. Bond dissociation energy means energy required to break the bond. Delta HF means what? This much energy is released. This much heat is released. Minus is called released, exothermic. 200 kilojoule of heat is released on the formation of 1 mole of XY. On the formation of 1 mole of XY, that is said per mole. So what is the relation between delta H and bond energy? We will see. Now this reaction we will take in terms of bond energy. This X2 we will write X single bond X. This 1 by 2 also we will write. Y2 we will write Y single bond Y. Now XY we will write X single bond Y. Okay. This X2 reacting with Y2 to give XY. That means between X and Y bond is produced. Between X and Y bond is produced means between this X and X bond should be converted into what? Such that X and Y are making a bond. So this X and this Y making a bond here for forming XY. Within the X2 bond is there, within the Y2 bond is there. What should be happen to this bond such that X is getting free here and Y is getting free here and X and Y making a bond here. So what will happen to this bond, or what we have to do regarding this bond such that X will get free, this X will get free and Y will get free and this X and Y come closer and make a bond and make a bond here and make a bond. So here this bond should be converted into what should be happen to this bond such that X will get free. Similarly you see what should be happened to this bond such that Y will be free, then X and Y will make a bond. This indicates that we have to break this bond. We have to break this bond, then X will get free. We have to break this bond, then Y will get free. Then this X atom and Y atom come closer and makes a bond, then XY will be formed. So this indicates we have to break the bond here. We have to break the bond here. For breaking the bond, energy is required. For breaking the bond, energy is required. Similarly, we have to break the bond. We have to break the bond here. For breaking the bond, energy is required. Energy is required. Here bond is produced. Here bond is formed. Here bond is formed. While forming a bond, energy will be released. Energy will be released. So we can say here release of energy, here requirement of energy, here requirement of energy. Now Energy required means it is endothermic. Energy required means it is endothermic. Here energy required, therefore it is endothermic. Here energy released, therefore it is exothermic. Therefore it is exothermic. Now we will see the relation between this delta H and bond energies. Delta H and bond energy relation, let us see. Now we will take this delta H, enthalpy of formation of XY, that is equal to energy required to break this bond. Energy required to break this bond. Okay, energy required to break the bond here. This is endothermic, therefore plus. It is how many moles? Half mole. So we will take half mole. Here also half, if you take 1 time X you will get. For to break this bond also energy is required. This is endothermic. Endothermic means we will write positive. Energy required to break the bond. Energy required to break the bond in Y2. It is half mole. If you take half mole, it will become 1 time Y. So 1 time Y, that half we will write here. Here energy is released. Release of energy means exothermic. Exothermic we will write as minus. Energy released when bond is produced. Energy released when bond is produced in XY. It is 1 mole, therefore 1 mole. Okay. Now delta HF we will substitute. Enthalpy of formation will substitute minus 200 kilojoule per mole. Next this 1 by 2 will substitute. It is bond energy of X2. It is bond energy of Y2. It is bond energy of XY. Regarding bond energy, some ratio is given. Bond energy of X2 is 1 time. Bond energy of Y2 is 0.5 times. Bond energy of XY is 1 time. So as per this ratio, X2 bond energy we will write as X plus this 1 by 2 into bond energy of Y2 we will write as 0.5 X minus bond energy of XY we will write as X. Now we got in terms of X, we got X is nothing but bond energy. Now we will simplify, we will get X. We are getting X. X is equal to 800 kilojoule per mole. X is equal to 800 kilojoule per mole. Now what is the question? Bond dissociation energy of XY. So bond dissociation energy of XY. Bond dissociation energy of XY. Bond energy of XY is X, that is 800. This 800 we will take. 800 kilojoule per mole we will take. Since it is a dissociation, positive. If it is formation, it is negative. Now they are asking dissociation, so positive. So 800 is the answer. So option for this question is D option.